Okay, lastly, we're going to look at what we call the combined gas law. And the name pretty much tells you kind of how it works. We've basically taken all of the gas laws that we've talked about and we've combined them into one law that shows where all of the variables stand in relation to the other. So if you remember, pressure and volume were inversely proportional, so they're next to each other here. And both pressure and temperature and volume and temperature were directly proportional. So we have temperature as the denominator on both sides of these. And this sort of expresses the relationship that they all have to one another. And we can use this gas law then in order to solve for any one of these pieces if none of them are being held constant. So, as we looked at in the simulator before when we were holding some things constant so that there were only two variables, now we're going to use all of this to solve for a problem in which all of the variables change. Okay, so we solve the exact same way. It's basically algebraic, and we're solving for the missing part of the equation. So what I'm going to do is I'm going to go ahead and put a problem up here for you, and I'd like you to take a few minutes and solve it, and then submit your answer into the Google form. So here's the problem. At sea level, we have a balloon that has a pressure of 100.9 kilopascals, a temperature of 25 degrees Celsius, and occupies a volume of 12.5 liters. We're going to take that balloon up into the mountains where the pressure drops to 92 kilopascals, the temperature drops to 20 degrees Celsius. And we want to know what the new volume of the balloon is. So we are solving for V2. So go ahead and use that formula and see if you can solve for this volume.